In this question, there's two long wires carrying current, and we want to find the magnetic field and the magnetic field at point P. So the first part is we know that current 1 is flowing into the page. It has a magnitude of 1.25 amps. The second wire has a current of 1.75 amps and it's flowing out of the page. So part 1 says draw the magnetic field vectors B1 and B2 at point P, which is 150 centimeters from the origin. It's essentially halfway between this wire and the origin. So let's draw those vectors. To do that part, let's remember what the magnetic field vectors look like. Magnetic field vectors make big circles around your wire. So the magnetic field due to wire 1 looks essentially like this. It's a big circle that cuts through P, and it has wire 1 at the center. If we draw a line from wire 1 to the point, that would be the radius of this circular magnetic field. To know the orientation, your thumb goes with the field into the page and your fingers show the way of the magnetic field. So at point P, it's a tangent, which means it's perpendicular to that radius, points away from it because of the right-hand rule. So there's magnetic field B1, comes down this way. B1. Magnetic field due to wire 2. So magnetic field due to wire 2 makes big circles around the wire, looks like this. Use the right-hand rule to see that the circles come around this way. So if we were going to draw a bit of that circle, it would look essentially like this. The magnetic field would be a tangent at this point, so perpendicular to this line, and points in the same direction as my fingers, which is straight down. So there's magnetic field B2. So that's part A, draw the two magnetic field vectors. The next part, find the magnitudes of B1 and B2 at point P. So let's find those guys. So the magnitude of B1 is equal to mu naught times I1 over 2 pi times R1. I1 is 1.25 amps. R1 is your distance from your wire to your point. We don't know what that is, but it's not that hard to figure out. So here's R1 in the picture. We know that point P is at a distance of 15 centimeters. So this distance from here to here is 0.150 meters. So our distance R1 is the hypotenuse of a right-angled triangle. It's the square root of 0.1 squared plus 0.15 squared. So that's our R1. That turns out to be 0.180 meters. So we'll put in 0.180 for R1, we'll put in 1.25 amps for the current I1, and we get a magnetic field of 1.39 times 10 to the minus 6 Teslas. Thinking ahead, we are going to have to write this as a vector, so eventually we're going to start thinking about angles. We can use a little bit of trig to find this angle, that those are perpendicular, we'll be able to find that angle, and then we'll be able to write our B1 in components. But for right now in this part, it only asks for the magnitude of B1 and B2, so we're okay there. So the magnitude of B2 is mu naught times I2 over R2 pi times R2. R2 is from our point to wire 2, so here's R2, and that's 0.15 meters. So 0.15 meters for R2, 1.75 amps for I2, and we get a magnitude of B2 as 2.33 times 10 to the minus 6 Teslas. So there's part 2, there's the magnitudes. For the next part, we need to find the magnetic field vector. So what we're going to do for that part is add those two things as vectors.